Hi everyone, welcome back to the channel. In this video, I am going to explain a practical 60 days roadmap to move from production support to DevOps engineer role. So whatever the role, if you are working L1, L2, L3, so you can focus on the 60 days. So definitely you can move from your support role to DevOps engineer role. Okay, so if you are currently working on production support, kind of application support, L1, L2, L3 support, or kind of any other technology testing or any IT support, so and you are planning to move into DevOps, this roadmap will show you what to learn in order to how to learn, and the end the hands-on work like what you need to complete to move from your support role to DevOps engineer. Okay, so here we are going to cover Linux, networking, Git, shell scripting, and basic Python, Docker and Kubernetes, and CI/CD with Jenkins and GitHub Actions. And the end we will cover cloud basic concepts of AWS and Terraform and Grafana. Prometheus and Grafana, these are the monitoring tools. Okay, at the end I'll also explain how to use your last 5 final days for the projects, like how can you integrate with GitHub documentation, application architecture and explanations, and how you need to deal with real-time issues, troubleshooting the scenarios for the interview preparation concepts. Okay, so here I'll cover basic concepts. I can say I'm not going to cover basic concepts like what you need to learn to move your current role to DevOps engineer role, and what to learn or what exactly you need to practice, that I'm going to cover. So I'll add for each topic, I'll add the specific YouTube URL or YouTube playlist link, so there you can go through, debug much more into application, I mean like that video level. Okay, so this is the 60 days roadmap overview here. Okay, so first 1 to 7 days we'll cover the Linux here. So what exactly you are going to learn here is, these are the concepts. Okay, so now let's move down here. Okay, so we'll start with the Linux. Okay, Linux is the one of the most important skill for both production support and DevOps engineering roles, because many application servers and DevOps tools runs in the Linux based environments. You don't need to learn every Linux command. Okay, so just focus on the commands where you actually use while supporting and troubleshooting the applications. So for that, mainly you need to understand the files and permissions concepts, then users, like how many types of users are there, that kind of commands you need to remember, and the grep, like this is the major command which we are using in the real-time scenarios that you need to know, and the sed and curl commands. So these are the these commands will be enough to deal with any Linux issues. Okay, and coming to this one, so if you want to see how much the disk space and CPU and memory, so these type of commands also you should remember. Okay, start with the files and directories commands, kind of cd, pwd. So pwd means like present word, present directory, like it will show you where you are exactly standing, and mkdir, it will help you to create the directories, and this cp, mv, and these are the major commands. So I'm not explaining like what the command it is doing here, because it will be, the video will be lengthy. So I'm just like explaining here like what you need to learn and how you need to learn. So what are the things you need to follow for your transition from whatever the support role you are working from to DevOps role. Okay, see, like, and I'll explain in the each topic like from 1 to 7 for Linux, and I'll give you one real-time example also. Okay, so for example, if the user sees reports of 500 errors in the production, okay, you can use tile to monitor. This is the tile command. Okay, which the tile command, you can monitor the application logs, and you can find out with the grep to set specifically any error. Grep, if you want to see find out any specific errors, kind of response codes or any particular error, so then you can use the grep to set specifically for that kind of exceptions or errors, any blockers. Okay, next we'll move to the process management, like disk troubleshooting. So these are the commands we can use here, df and du. So I'll give you the video link also. So if you want to practice for Linux videos, I mean Linux playlist for DevOps, I'll give you the in the description for each topic. I'll give you the video URL also, then you can go through that particular video. Okay, so these are the things which you need to learn for the like for the Linux. Okay, so now once you are comfortable with the Linux troubleshooting or Linux commands, then next steps is understanding how the application communicate over the network. The second week the plan here is day 8 to 12 networking concepts. Okay, we'll spend the next 5 days learning network basics here. So you don't need to become a network engineer here. Okay, but as a production support or DevOps engineer, you should understand what happens when user enters the application URL, why that application sometimes become unreachable. Okay, these are the basic flow. Okay, so these are the network basic flow here. So this is what you need to focus on things here. Okay, this is the protocols HTTP or HTTPS. This is the TCP IP. So these, like, this is where your application hosted, like particular port number. This is the IP here. So this is the load balancer, how the your application is configured with the load balancer. There is different types of load balancer configurations, round robin under on different types. So that we'll see in the next videos, or I'll upload the playlist for the specific topic. You can go through that. Okay, so for example, if the user says like the application URL is not working, so you can investigate in the step by step. So you can use that application.com URL ns lookup. So check that connectivity first of all with that application, the connectivity is there or not. Then you can check with the curl command. With that, using the curl command, you can give that endpoint and check the port and check the load balancer, check the certificate is configured or not, and check the backend application, where it is redirected in the connected in the backend. Okay, and also understand common HTTP status codes like 200, 400, 401. This I am not going to explain here because already I have written here, so you can just go through, because most of the people know what is the 500 codes, what is the exactly meaning of that, right? Okay, so now we understand that basic Linux and networking flow. Now let's move to Git and GitHub. Okay, as a DevOps engineer, you may not to write application code every day. Okay, but you will regularly work with the source code, configuration file modifications, Docker files changes, YAML file modifications, Terraform code, and CI/CD pipeline files. These are the files are normally maintained in the user using the Git. Okay, so this is the basic flow. It will merge to the main branch here. Okay, so this is the flow here. You can go through the complete playlist for the Git and GitHub. I'll add you in the description. Okay, so for the coming to the real-time example, suppose the API payment API has the production bug. Okay, that the developer creates a branch. So he's trying to fixing that. Okay, he'll create the branch here. Okay, so then after fixing the issue, he will mention here git status, git add. Okay, once this issue is fixed, he'll commit this whatever the he changes, right? So he'll commit these changes, git commit fix payment API timeout. Okay, then he'll push the git push. Okay, this is the payment. Okay, once the PR is raised, then the lead or manager will review your code review, then he'll approve, and it will merge to the main branch, and it will merge to the, because it's all this code are deployed to the here GitHub. Okay, then it will integrate to the CI/CD. Okay, in the simple terms I can say, once the developer fixes the production bug, it creates or works on a branch. He commits his fix. Okay, and he raises the pull request. Then the team reviews, or manager will review and merges it to the main branch. Then the CI/CD pipeline deploys the change. Okay, so for especially, as I said, so I'm adding the complete playlist link here. You can go through. Okay, so once you understand how changes and are stored to the manager in Git, the next step is automating the repetitive operational kind of tasks. Okay, then day 18 to 22, so where we are going to focus on shell scripting with Python. Okay, so production support teaches us how to perform kind of operation tasks. Okay, but coming to DevOps, it takes one step further by asking, like, can we automate those repetitive tasks? For example, instead of manually running like this command every 5 minutes, like application health to check with curl command, so you can create a health check script that runs and check automatically. The basic concept is, we can call the application, check the HTTPS response. Okay, if it's 200, yes, it is up. you can send the alert. If it's up, okay, then it is good. If it is not up, then you are seeing no, then you can raise the alert. Okay, so other useful automation examples including log pricing. Okay, these the grep, like where exactly you need to find out the error log. Okay, so you can also automate kind of the disk monitoring, disk usage, comparing it with threshold values, send out the alerts if the like CPU and memory is monitoring is already reached limit, so then we can send out the alerts. Okay, kind of automating task where we are going to do. So for that you need to learn Python to work with the you need to learn bash and Python to work with files and APIs, JSON, kind of doing the basic automation. Okay, so now that we can automate basic tasks, so let's move to Docker and learn how applications are packaged with consistency across all the environments here. Okay, we'll move to day 23-27 for the Docker. Okay, see, Docker is a containerization platform that packages an application together with its runtime and dependencies into the Docker image. So that image can run as a Docker container on any system that has Docker installed. Okay, so earlier what's happening is developers often said like it works on my machine. The same application could fail in a test or production environment because of different types of Java versions, missing libraries, or configuration differences, right? Because see, in my application the Java, like it will work due to some environmental changes or kind of different versions, but in prod or test machine it will not work. So that's where the Docker helps solves this problem by creating a consistent application package that can be used across all the environments like testing or development or PT or prod. Okay, this is the flow here. Application, so where we configure the Docker files with we can club this Docker image and the Docker container. So you can go through all these concepts because it's the mandatory things if you want to learn debugging more into Docker. So you need to learn all these concepts because I'm not explaining here. Okay, because if I'm explaining all these things it will take more time, so that's what I'm giving the basic idea to go through. So here this is the real-time example. If the developer changes the code, Jenkins builds it and Docker image is created, the image is pushed to registry, the same image is deployed to test or production. I think now you got some idea after seeing this one. Okay, yeah, so if a container fails, like where we are going to image deployed, right, so then we can use Docker with like logs, check the logs and status, will troubleshoot further. So now we understand that Docker, right, how the containers works. Now let's move to the Kubernetes, which helps us deploy, manage and scale multiple containers. Okay, so we'll move to day 28-35. Okay, this is the Kubernetes. So Kubernetes is a container orchestration platform used to deploy, manage, scale and recover container applications. Okay, we start with these concepts main, the parts. Okay, these parts will runs with the application container. Okay, okay, it will, the parts here is for that application they'll allocate few parts like minimum as 1 or maximum as 2 or minimum as 2 or maximum as 4. So within their limits only these parts will scale up, because this is a kind of the cloud based, right? If the application is consumed less CPU or memory, it won't scale up. It will consume only with the, it will run with the minimum parts only. If the usage is more, then it will consume to like it will increase or scale up to maximum range. Okay, so this is the deployment where we can manage the parts and like kind of replica sets, like we can delete the parts if you don't want for that application, so we can delete that parts. Okay, this is the service where like it routes the traffic and ready application parts. Okay, this is the configuration maps. Okay, where stores or application the configurations. For example, how this configuration will work means, so any application, the endpoints, okay, port numbers and kind of the certificate details here, all these things they'll update here. Okay, in the store like configuration part. So secret here, it will stores the sensitive data. If it's application related, the encryption, decryption certificates or keywords, it will update here. We can update the probes, right? It will check the application health and readiness. If application is ready for once we have restarted, we can see the application's health and readiness here. This is the resources here where we can monitor and CPU and memory requests and limit. We can limit, okay, in YAML file itself we can limit our CPU and memory request. Okay, like if you want to run with this kind of limit like CPU and memory, we can reduce and we can modify based on the usage. Okay, there will be different environments where we can modify all these things. In the prod we don't have directly access. In the PTA or testing environment we can do all these changes and we can validate. Then these changes will be moved to prod based on the requirements. Okay, HPA, as we discussed already, it automatically scales up the number of pods based on the metrics as we discussed. See, like if we are running with the, if we are application, we are, for example, application are on the like application side, people are using that application 100 members. Okay, it's running with the minimum part with the minimum 2 parts. Okay, but the maximum we have given 4. Suddenly the users are increased from 100 to 10,000. Okay, now the applications, it's automatically scale up because of the load. Okay, there is a limit for that CPU or memory. So based on that, they'll HPA, this horizontal pod auto scaling, it will be configured. Then the another new pod will be spin up and it will consume the traffic. Okay, this is where like user, this is the user, the service where we are trying to access this service, pod 1, pod 2, pod 3. These are the maximum pods. Okay, minimum is pod 1 here. See, like if the pod 2 crashes, so Kubernetes can create a replacement pod through deployment and replica set. At the same time, that's what, like if the one pod is, if the particular pod is crashes, automatically another pod will create. Okay, then that pod will consume the traffic and to the user, like it will serve to the endpoints. This allows that application remain available through the healthy replicas. Okay, so like that time also, like the another pod will consume. Okay, these are the only main reasons Kubernetes is widely used to run containerized applications in production. Okay, now we learned concepts with the Kubernetes, right, in the first step. So we'll focus on the how to troubleshoot common Kubernetes production issues here. Okay, this is the Kubernetes troubleshooting here. So during these 4 days we mainly focused on troubleshooting common Kubernetes production issues. Okay, this is the commands which you need to go through. You can go through all these commands. Okay, this is where we are like loopback. Oh, this contains, see, crash, loopback, and OEM, like out of memory kill, like where the container exists memory limit. So these are the commands which we need to go through, like CPU throttling, like trying to use more CPU, like configured. This will allows limit allows. Okay, this is the concept. This is the major major things, so which you need to learn here. Okay, yeah. So now coming to the real-time example, suppose the application becomes slow. Okay, check the pods, run kubectl top commands and identify the pod using like high CPU, check the logs once, identify the resource or configuration issue, fix it, like redeploy once, try to, and restart once and continue monitoring. Okay, a simple troubleshooting flow is like if you are seeing the alert, then check the pod status and check the logs and check the events and check the CPU and memory, find out the root cause, fix and redeploy and validate. This is what happened like for the Kubernetes troubleshooting issues. This is the major thing. Okay, so once you can deploy and troubleshoot the applications in Kubernetes, the next step is automating the complete build and test and deployment processing using CI/CD. Okay, so coming to the CI/CD part, where it's kind of the automates the process of building, testing and deployment of the application when developer makes approved code changes. Okay, like you can use this for this one Jenkins or GitHub Actions to create this pipeline. And the typical flow is, if the developer is like move the code to GitHub, the Jenkins or GitHub Actions, then it will build, it will automatically build and it will test and like it will run particular test cases and it will prepare the Docker image. There you can in the registry, then it will deploy in the the Kubernetes application and it will deploy in the prod. Okay, this is the flow here. So coming to a real-time example, a developer fix a production bug. and he merges the code into main branch, the CI/CD pipeline automatically builds the application, and it will run JUnit or whatever the required pre-required tests, and it will create Docker images, and it will push that image to registry where, like using the cloud like AWS ECR, and deploys the new version to Kubernetes. If any stage this stage fails, the pipeline stops. The DevOps engineer checks the failed stage and it logs and fix the issue and rerun the pipeline. Okay, this is a simple interview point. Interview point is that CI/CD makes deployment faster, repeatable, and lesser error prone than manual deployments, because earlier we used to do all this manually. So now we can implement with CI/CD. So now that we understand the deployment pipeline, right? So let's look at the AWS services commonly used to run IaaC, like infrastructure in the cloud. Okay, here we'll move to the day 45 to 48 AWS cloud. Okay, for the DevOps engineer, you don't need to learn every AWS services at the beginning. Focus on the core services that are commonly used in application deployments and operations, that are called IAM, where we can manage the users, create the roles and permissions, and easy to provide like kind of virtual service to run applications. We can give access, and S3 like storage, provide the storage for the files and backup artifacts. This kind of, and auto scaling, where we can add or remove EC2 instance based on the demand. And this CloudWatch provides like monitoring the logs, metrics, and alerts. It's an inbuilt one. And EKS, like how we can manage Kubernetes services. This is the major topics which you need to learn for DevOps engineer. And coming to the real-time DevOps flow, can look this like this is the one, like user can access the application through this flow. Okay, you can go through this one, where we can monitor with the CloudWatch the like environment and generate alerts when issue occur. Okay, for the production support to DevOps transition, focus especially on IAM, EC2, and CloudWatch and EKS. Okay, these are the topics which you need to go through. So after learning the cloud infrastructure works, the next step is learning how to create infrastructure using code instead of doing everything manually. Okay, so coming to the Terraform, day 49 to 52. Terraform is an infrastructure as code or IaaC tool. Instead of manually creating AWS resources from the console, we define infrastructure using code. Okay, these are the concepts which you are going to learn for the Terraform, in the Terraform for the DevOps. You can go through all these things. Okay, so next, like this is the flow for DevOps flow. Okay, so once the application and infrastructure are deployed, so we need to continuously monitoring their health and performance. That brings us to monitoring. Okay, so we move with day 53 to 55. Here is the monitoring part. So monitoring helps DevOps engineer understand the health and performance of application infrastructure. Okay, so like important tools which we need to learn: Prometheus, it will collect applications and Kubernetes metrics; Grafana, where we can create our dashboards and visualize the metrics; and Cloud. So in Grafana itself we can monitor, and CloudWatch is inbuilt for the AWS one. So where the provides AWS monitoring for metrics, logs, and alerts. And important metrics like where we need to monitor include CPU, memory, response time or latency, error code, and these are the major things which we need to monitor. Let me highlight here. Okay, so coming to the real-time example, suppose the users report the application is slow, we can check the Grafana alert, check CPU or memory, so identify the high CPU part, check logs, find the root cause, like we can fix that one, and we can redeploy and monitor again. The same thing where we are doing in the Kubernetes. Okay, for example, if CPU utilization suddenly increase, the DevOps engineer checks Grafana and Prometheus, identifies the affected Kubernetes part, like an investigator that affected part, logs and resource usage, and he fixed that issue and validates the CPU usage and response time, return to normal. Okay, this is the monitoring flow. Okay, so if application is using the Prometheus and Grafana, if alert comes, the DevOps engineer troubleshoot and he fixed that one and validate. Okay, so now by this point we have covered the main technical areas in the roadmap. So now the final 5 days are of putting everything together through hands-on projects for the interview preparation. We move to day 56 to 60 project plus interview preparation. So use the last final 5 days to complete the 2 projects mentioned in your roadmap. Organize the project code and documentation in the GitHub. Practice everything in the architecture wise and prepare common troubleshoot scenarios for interviews. Okay, so also practice explain what would you do, check when the deployment fails, a pod crashes, CPU or memory usage becomes high, or that application becomes unavailable. Okay, so here complete 60 days roadmap to move from production support to DevOps engineer role. The goal is not become an expert in every tool within 60 days. The goal is to build strong fundamentals, understand how the tools connect with each other, and get enough hands-on practice confidently, and like explain the real-time DevOps workflows and troubleshooting scenarios. You can explain in that manner. So follow this roadmap step by step. Practice the commands yourself, build the project, and document your work in GitHub. So if you found this roadmap helpful or useful, share this video with someone who is planning to move into DevOps. Thanks for watching, and I'll share the all the playlists for Linux, Kubernetes, Docker, all the playlists in the description. I'll see you in the next video. Thanks for watching.